Hello, it's Scott Manley here. Last night, Firefly Blue Ghost landed on the moon, and this was one of the highlights of the images that was released. We've only got a handful of images, and frankly, I was hoping to have more to work with to discuss this. You know, the more you look, the more there is to discuss. So yeah, what we're seeing here is the shadow of the spacecraft landed on the edge of a crater. In the distance on the other side, there is the Earth, and of course behind it is the sun. That's like a 4K image from what's probably something similar to a GoPro, because I understand that that's what's used for a lot of these engineering cameras. I really hope that they were recording that during the landing, because with the backlighting, that could provide some really useful scientific data on how the rocket plume interacts with lunar regolith, but it would also look jaw-droppingly awesome. The landing was, of course, Firefly's first attempt to land a spacecraft on the moon, and they'd watched everybody else before them, and they had learned, first of all, the software is really important. They didn't really have any serious bugs. They did have one bug, but it wasn't a showstopper. Descent towards the surface pretty much went exactly as predicted. You'll notice, by the way, at this point, they still have the center engine running, and it just shut off. There was a lot of art that was used on various other sites that showed that center engine running all the way to the landing. That was a Leiros engine made in the UK by Nammo, which is a high efficiency engine, but it provides over 1,000 newtons of thrust, and that would have it having too much thrust once it got down to the surface. So instead it switched over to these 8 small Spectre engines, and we're told these have a total of 1,600 newtons of thrust between them, so that's 200 newtons each, and they are able to throttle down, or at least pulse their thrust so that they can accurately control the thrust all the way down to landing and make a soft landing. They use the same propellant as the core engines, monomethyl hydrazine and nitrogen tetroxide, standard hypergolic mixture, and of course in the simulation you can see these little jets shooting out. That is not what you would see on the moon, because there is not sufficient atmospheric pressure to keep the gases hot as they emerge. Now, also an important thing to look at in this telemetry diagram is the yellow arrow that's extending out from that solar panel. That's pointing towards the sun is, and the blue arrow, that points towards where the Earth will be. And that was useful for confirming that the spacecraft came in from the north. Anyway, look, it's getting down below 10 meters, and it's basically slowing down to a landing. So again, the trick is to get both of these numbers, the altitude and the velocity, to 0 at the same time. And what's interesting is it suddenly jumps up from 1.4 to 877, like 696, but notice these sensors on the feet have all gone out. So yeah, that was them landing on the moon, and that was the software glitch that was public, that the fact that the telemetry display in the stream looked like it was displaying millimeters, but it didn't actually show millimeters, because that would make far more sense. They're a couple of feet above the surface, or at least the sensor is 69 centimeters above the surface. And indeed, one of the foot sensors doesn't appear to be resting on the surface with sufficient force to trip its contact sensor. And these are worth mentioning because they use a deceptively simple design. And so while everyone in Mission Control is taking a well-earned moment to celebrate, and there was actually a big party in Austin, which I couldn't get to, but it was cool apparently, let's talk about those feet. Look, I mean, I know a lot of you aren't really into feet, and those people that are into feet, this is not that kind of feet, but it is just, it's worth mentioning, right? So they're basically like walks, right? And when the spacecraft was assembled, they were aligned more or less straight out with those big landing struts there. And so you can imagine that when weight is put on these, they're going to want to rotate and twist flat. They are actually connected to the struts via a ball joint, which you can see here. So the contact sensor is literally a brake wire which runs on the outside of this. And as the pad is bent around, the wire breaks and the sensor goes off. So now, why did only 3 of them trigger? Well, that's probably because there's differences in the terrain on the moon. Maybe one of them landed on a rock which didn't actually allow the pad to roll over correctly. So now, if we look back at that photo taken off the shadow, if you look at the pads on the right side, they both look kind of flat, as if they've turned. The ones on the left side here, one of them looks like it's oriented in its pre-landing position. Now, I can't be sure about this. That could actually be shadowing in the terrain, but
I'm going to point out it's actually a really cool view here because it looks like we can see a fairly well-defined shadow showing the structure of the vehicle landed on the moon. And if we zoom a bit further out, you can see the wider context, and of course you can see the planet Earth up there. But it's really hard to get a sense of scale on this image. How far out is that going there? How big are these craters? Well, we actually have a pretty good idea about how wide the lander is. So at the point between those two landing legs, we know exactly how big that is on the surface. But the rest requires that we understand, where the light is coming from. And to do that, I need to answer the question that everybody keeps asking. Where is Blue Ghost on the moon? They say, I want to be able to look at the moon and see where it landed. Well, good luck with that because the moon is a very thin crescent right now. But in a few days, you'll be able to see it. So yeah, it's in this region here, the circular region. It's called Mare Crisium, and that's roughly the landing spot there. Now, this is on the right side of the moon if you're in the northern hemisphere, the left if you're in the southern hemisphere. It is a mare, which means it is a flat region where there has been a volcanic eruption, which has created a sea of lava, which has subsequently created nice flat terrain. And then later, of course, we've had, impacts that have made it a bit more rough. Now, the specific coordinates are around here. This is a structure here called Mons Laterale, I think. Former volcanic activity, and we're up around here. It's 18.56 north and 61.81 east, and it's much better if I switch this to the equidistant cylindrical projection here. So we can zoom, and you'll see the resolution down in the bottom right corner of the screen. This is like 100 meter resolution down here, you can see. So I think this is roughly where it was supposed to land, and we know that it landed within about 100 meters. But that could be 100 meters, either side with fairly long cross range. We're not 100% sure. Now, the sun is coming in from this direction, and the Earth is off roughly in this direction because it's near to the edge of the moon. We actually have exact solar and Earth coordinates for this time, so we know what way the shadow should be pointing. We also know that the sun was very, very low on the horizon, to the extent that the shadow of the spacecraft when it was photographed could be anywhere from 20 to 30 meters long. And so on this scale, 20 to 30 meters is quite long. And then you consider that it doesn't even start until partway through. You could have a shadow going a fairly long distance across the moon here. So that gives you an idea how big the craters are in that image. We can also take a stab at the field of view of the camera by measuring angles of things that are known. For example, the size of the Earth, it's 2 degrees in diameter. The elevation of the Earth above the horizon is known. The angle between the Earth and the shadow, right, because it's the angle between the Earth and the sun, that is known. That gives us, the numbers go from like 110 to 140 degrees, and it seems reasonable that this would be a sort of wide-angle action camera like a GoPro with a field of maybe 120, 130 degrees. Of course, if you zoom out, you can see that with a wide field of view, the horizon is curved, and that is just due to lens distortion. The horizon is a little below the center point, and so towards the edges, it drops down more. I'm not going to go and measure the lens distortion from that, but you just get the idea that it's going to be critical to measuring anything. Now, if we zoom back in and look at the shadow, is there anything else we can see? So first of all, obviously you can see the big Leiros engine that's extending below the bottom. To the left of that, hanging off the bottom, that is the Lister experiment. That's the drill that's going to go into the surface. If you look at each side, there's these sort of bits that jut out. Those are the RCS thrusters, the Spectre thruster assemblies, which were used for the landing. Going up to the top, you can see 2 things extending above it, and one of them is like sort of poking out at like an angle towards 1 o'clock. The fact that we can see that tells us how far away that shadow could be, because that is from the Lexi X-ray telescope, and according to the designs, it is using a square casing which is 19 centimeters across. Here's an image of that experiment from another camera on the spacecraft. And here's some plans showing the dimensions of that object. Again, 19 centimeters across at the base with a square cross-section. And so now if we look back to this image here, you can see that it has a dark, well-defined umbral shadow, right? That's the technical term. You've got the penumbra, and then you've got the umbras where it's properly dark. This is what we have in solar eclipse, right? There's only one part with deep shadow because there's a finite angle between the left side of the sun and the right side. It's half a degree across. So for 19 centimeters, it should only produce a dark shadow up to about 22 meters out. But this is a box shape, so you have to multiply that by, 1.4 because, it could be the diagonal angle. And so that would be just over 30 meters. So we know that this cannot be further than 30 meters away from the spacecraft. There's another illustration of this effect, by the way. If you look at the two landing legs here, now they're not quite in line, but one of the landing struts, the inner one, looks darker. And that is because it is the one that is closest to the shadow. The shadow has had the least amount of time to spread out. And similarly, on this side, they're much, much thicker because the terrain is such that we're looking into a crater, and the crater wall on the left side of this image is actually closer to us, and that's why the shadows of the legs are thicker. There's also one other thing I want to draw your attention to because I can't figure it out. There's struts that are open on the left side, but on the right side, you have this solid block, and that's because they've strung mylar, MLI insulation between these two struts. It's only on this leg, it's not on any of the other legs, and it looks more like it's to maybe block exhaust. There's no scientific instrument or anything on there. It's just something that really, piqued my curiosity, let's say. So anyway, coming back to the full frame, this is it in all its glory, and I tried to figure out if I could match it to any specific set of craters, and, well, it's a lot more difficult than I expected. First of all, the illumination on the terrain is wrong from the camera images. That was just because of the time they were taken. But you can actually fix this using a clever trick called inverting the image, so the shadows are now light areas and vice versa. I created a little mask that I could move around the image, and then finally found a few different places that potentially mapped, but the best place I came up with was this place down here, which was great until this morning, when this came out with a bunch of craters that I couldn't quite map. And again, look, this is really hard because the scale of the craters is so much smaller than the scale of the imagery we already have. This is obviously a camera pointed in exactly the opposite direction. And they say rise and shine, it's catching its first sunrise. I mean, yes, technically it's a sunrise, but they landed during the sunrise, so they didn't actually see the sun rising above the horizon. There's another camera on top, and this caught, of course, the Lexi instrument and the high-gain antenna. But it also caught the planet Earth, and the planet Earth's details are totally blown out, totally overexposed. But if you move the camera downwards, you can see there's a pretty good reflection of our blue planet in the solar panels. And because the panels are black, they've attenuated the image, and we can actually see some detail of the clouds, the oceans, the continents. It's a little distorted, but nevertheless, it is pretty cool to see this kind of detail coming from what is basically an engineering camera. Now, this deck-top camera has also caught some other cool images during the mission. First of all, we have the high-gain antenna turning and pointing towards the Earth. That'll deliver more data. Obviously, what we've got is kind of limited. That antenna also includes the LUGR experiment, the Lunar GNSS Receiver experiment, which is basically already demonstrated it can receive GPS signals while in lunar orbit. And you might notice in front of the antenna that there is some stuff peeling up there. We've seen that slowly coming up through the mission. I'm guessing it just wasn't bonded correctly and the heat is causing it to curl. Hopefully it's not going to interfere with the rest of the mission. And there was another thing in the antenna deployment that elicited a Whiskey Tango Foxtrot moment. Now, it looked like there was a tiny little gold lander in the crater. And I spent a good few minutes racking my brain over this. Was there like a sub-spacecraft we didn't know about? Did China beat them to this particular crater? No, actually, it looks like it's on the lunar surface. There's lunar surface reflecting off the solar cells, and that's just like a piece of the structure sticking up over the edge of the solar cell. So it looks like another bit of spacecraft in the distance. Whew, at least it wasn't aliens. So there was two other images from engineering cameras. This one was the first one, I believe, that came down after landing. So compared to the image with the shadow in it, this must be on the left side of the spacecraft looking down. And the structure at the top there, that's the RCS, the Spectre thrusters. There's a pair of them inside there. And this is obviously looking directly down the side of the spacecraft. So to the right, that is the glow of the sun rising in the east, and you can see the shadows that are sort of pointed towards the west there, to the left side of the image. This is from a couple of meters above the surface, so if you were very tall and looking down, this is kind of what you would see. That, just to get you an idea of the scale of these craters, they're tiny little potholes. We get a slightly better exposed image from the other side of the spacecraft. You can just catch one of the landing pads on the bottom left there. So again, this looks like it's a sort of darker area, so this looks like the terrain has sort of begun sloping downwards. So it could well be that this is sitting on the rim of a crater. That kind of matches what the other images are showing. I'm not sure if this position is good for some of the experiments or bad for some of the experiments, but I just really hope that we start seeing some data from these experiments in the next few days. One final thing they showed on the stream, which I was really excited, really happy that they brought out, was when one of the presenters just brought out one of the Spectre engines, and you'll notice that she's wearing like gloves, because this is a test-fired thruster, and when you test fire it with hydrazine, that is potentially very nasty neurotoxin stuff, and as much as you clean it off, you still want to be very careful you're not transmitting anything by touching it. So I think this is cool. It's just a simple pressure-fed thruster called a Spectre. Obviously, in the rocket world, we give a lot of love to the big engines, the Merlins, the Raptors, the Reavers, the Mirandas. Don't give nearly as much attention to these small utility thrusters. This is totally something they developed in-house. It's a very simple, pressure-fed design, but it's cool that they actually brought this out. As I said, these thrusters are paired up. There's 8 of them around the spacecraft. I suspect that they could actually handle a failure or two of these thrusters during the final landing phase. They have 1,600 newtons of thrust, and I think the dry mass of the spacecraft is about 500 kilograms. So maybe 4 of the thrusters would be sufficient to put it safely on the surface. Having said that, I'm glad that they all worked. So anyway, congratulations to Firefly and everyone involved. Whoever does your software for your display, you can fix the millimeter thing. Congratulations on landing on the surface of the moon. First try, successfully. No RUDs, no litho braking, no broken landing legs, and within 100 meters of the intended target. Good job. I'm Scott Manley. Fly safe.